Okay, hi everyone. My name is Valentin, and I have 10 minutes to make sense out of that weird title, so we'd better get started yet. And in fact, I will start with the question Pavel just asked us, which is, what is it to be a software engineer, a software developer? What is the essence of our job? It's a pretty simple question, right? Let's try to answer it. So basically, someone come to us with an idea of something that can be achieved with computers. And like Angela said yesterday, we light up our powerful, massive brain. We feed it with some hot beverage. And after a while, we end up with, well, mostly bugs. So of course, this is a very simplistic picture. The real essence of our job is really much more complicated than that. If we were to completely understand it, we would have to talk about physics, electronics, logic, mathematics, compiler theory, and even sociology or psychology. Because the whole process of building software is not just to write some text in a programming language. What matters is the value that it brings to users. And so it's a very, very complex environment. And we have only one tool to help us manage complexity. And this tool is abstraction. With abstraction, we are able to hide some useless detail and concentrate on stuff that matters. With abstraction, we were able to understand like mechanics and send people to the moon. It's a very powerful tool. But the problem is that even if abstraction helps us to make things that are complex simpler, new abstractions are always difficult to understand. But fortunately, we have another tool, which is also very convenient, that helps us to understand new abstraction, and it's metaphors. With metaphors, we are able to connect something that is new and abstract to something that is already known and more concrete. For example, this is probably one of the first metaphors people use in order to understand a new abstraction. When children learn how to count and how to deal with numbers, they use their fingers as a metaphor for numbers. Raising one finger is adding one, putting down one finger is subtracting one. And so you're able to learn how to count and do very basic arithmetics. But if you want to really learn mathematics, at some point you have to unlearn the metaphor that helped you in the first place to understand the concept. For example, you cannot do division with your fingers. So at some point, children have to unlearn the metaphors that help them understand numbers. So let's sum it up. We have a problem that is complex and difficult. With abstraction, we make that problem more simple. And with metaphors, we make this abstraction more easy to grasp. So have we found some kind of holy grail that makes things that are complex and difficult simple and easy? Well, quite not. The problem is, metaphors are not a very solid tool. They have many problems. First, a metaphor is always connected to some specific cultural context. For example, if I say to you, you know, monads are like burritos, but you don't know anything about Mexican food, that metaphor is of absolutely no use for you. And we could argue that this metaphor is of no use for anybody, but that's another debate. Metaphors do not come with a set of laws that allow you to use them to discover new things. They are really just, throwaway tool. You don't can get new knowledge from a metaphor. And finally, one of the most important problem with metaphors is that they tend to stick with you because they make things easier. And so it's really tempting to get stuck in a metaphor. It's like children who had to unlearn to count with their finger. It's really hard to escape from a metaphor that you've been using constantly. And we could also argue that the metaphor we use on a daily basis, they tend to shape how we see the world. And there is a set of metaphors that are completely pervasive in our industry, which is the metaphor around the vocabulary of construction. You know, we have architects, and we do plumbing, we use building blocks, and we are software craftsmen. And taking what I've said about metaphor, I think this set of metaphors we use constantly, they give rise to what I call the Carpenter mindset. The Carpenter mindset is that idea that our job is exclusively a creative one. We are creating designs, we are building stuff. The problem is, when you create something, you become overly attached to it because it's your creation. And so if someone comes to you and says, well, you have to change this and that because that's not what we want, it can be frustrating. Also, craftsmen and carpenters are very attached to their tools. And when we are in the carpenter mindset, we are somehow slaves of our tools. I would have some anecdotes about that, but I have to shrink it up. But when we are prisoner of metaphors, we forget that these metaphors that were only good to help us understand new abstractions. And these abstractions are the things that really matters. And they have a whole set of very good properties. They are universal. Monads are the same everywhere on the planet. And probably they are the same everywhere in the universe. There is no cultural baggage needed to understand abstractions. They are permanent. There will not be any version 2 of category theory that will obsolete what we know about functors and applicatives and so on. Once a theorem is proven, it will never be unproved. So grabbing abstraction is something that will stand and be permanent. And more importantly, abstraction comes with a set of laws. These are these laws that enable you to detect functors and monoids in the wild because you see something that is a certain pattern and abides some laws. And these laws also give you a way to compose these abstractions. And if we concentrate on discovering and finding abstractions in the complex problem we have, we use what I call the cartographer mindset, which basically considers that our job is mostly a job of discovering abstractions inside the business requirements. And so when the business requirements change, it's not a problem. It's just an occasion to get out and discover new abstractions. So we have this carpenter mindset and this cartographer mindset. And actually, you encounter carpenters more than cartographers, but these are really dual of one another. The carpenter tries to project some order onto complexity, whereas the cartographer tries to extract knowledge from complexity. And the takeaway of all that is that we should use both mindsets, but in a very specific order. We should always try to first do cartography and find abstractions inside the problem we are trying to solve. And once we have a good map of that land, we can build on that territory. And so, always do cartography before carpentry. That's it. That's all I have. Thank you very much.